Welcome, I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. I talk about laboratory compaction test. From the compaction test, I will show you how you have to calculate the different parameters. For example, we want to some calculation. Number 1 is the weight density. So, this is designated at gamma weight, unit is gram per cc. So, this will be defined as weight of soil compacted in mold. This divided by volume of mold. Then second parameter is the dye density. And dye density is expressed as gamma d, and this gram per cc is equal to gamma of weight, this divided by 1 plus m, where m is equal to moisture content. And number 3 parameter is void ratio, and this is designated at E. This is equal to G into gamma W divided by gamma of D minus 1. And number 4 is porosity. And this is designated at N and expressed in terms of the percentage, that is N is equal to E divided by 1 plus E, this into 100. And fifth parameter is degree of saturation, that expressed as S, and that in terms of the percentage, this is equal to G into M divided by E into 100, where G is true specific gravity, gamma W is unit weight of water, and M is equal to moisture content. So, these are the parameters are very important for the determination of dye density, void ratio, porosity, and the degree of saturation. Now, I will show you some specimen calculation for the standard Proctor test. Now, we use that Proctor cylinder. Now, this size of the Proctor cylinder, it has a diameter, let us say diameter is about 10 centimeter. It has a height is about 12.73 centimeter, and it has a volume is equal to 1000 cc. Now, we have also the Proctor hammer, in which we compact the soil sample. This Proctor hammer, this is Proctor cylinder. So, standard Proctor hammer has a weight is about 2.6 kg, and it can be dropped from a height of 31 centimeter, and you have to provide number of blows. Number of blows, that is about 25, and number of layer. When you compact the soil, you have to compact in 3 layers. And we have also empty weight. Empty weight of Proctor mold is about 2300 gram. So, with this we record for the what will be the shape and size of the Proctor cylinder and the Proctor hammer, and I am just showing you that this is the kind of the equipment. This is the Proctor, this is the Proctor cylinder, okay. And this diameter is about 10 centimeter, and this height is about 12.73 centimeter, and this has a volume, that Proctor cylinder has a volume of about 1000 cc. And we have some also the Proctor hammer. So, this is the sketch here, it is that shown, which you can see also here detail. This is 1800 millimeter diameter, this is 150 millimeter, this is 15 millimeter, this is base plate, this one is the base plate, and this is Proctor mold, and this dimension is 110 millimeter, and this is 120 millimeter, this is extension collar here. So, you can see this is extension collar here. So, this is the typical mold for compaction. And similarly, you can see here, this is the standard Proctor hammer, and it is dropped from a height of about 31 centimeter, and you have to compact the soil, number of blow 25, and number of layer is 3, and then this is details is given here. I am just explaining here. This is the 60 millimeter, this is 581.5 millimeter, and this hammer is 130 millimeter, this is 150 millimeter, and this is 500 millimeter, this is 65 millimeter diameter, and this is 20 millimeter. So, this is the typical metal hammer for compaction test. So, we use this equipment for the compaction test. Now, I will show you some calculation how you can determine this the dye density and the moisture content of the soil. So, here you can see that weight of the soil mole is gram, and I am particularly mentioning this row, that weight of the soil mole is 3995, this gram, and this is weight of the soil is 1695 gram. Then you can determine that weight density gram per cc 1.695 gram per cc, and this is the moisture content determination for this is the can number this, then you can you will be knowing weight of the soil plus can is 73.51 gram, then dry soil plus can is 68.78 gram, then weight of empty can is 36.45 gram, and then you can determine the moisture content, that is about 14.63 gram. So, for different tall number you can determine all these parameters, and then you have to calculate the average moisture content. So, you take the average moisture content, it may comes about 15.04 percentage, then you calculate dye density, that is 1.473, and the void ratio E is 0.697, and degree of saturation is 53.9%. This is I am just showing you one of the typical calculation here. Now, I can show one calculation that how you can determine this. So, first is that weight of soil plus mold. Say this is 3995 gram. Second, you take that what will be the weight of soil. This is 3995 minus 2300. So, this will give about 1695 gram. Okay. Here weight of empty mold is equal to 2300 gram. So, here weight of empty mold 2.300 gram, and that is why weight of the soil is 3995 minus 2300 gram is 1.695 gram. Next, weight density. Now, weight density is weight soil, that is 1695, okay, and that divided by, you know that volume I showed you earlier, that is 1000, that means this will give you 1.695 gram per cc. So, you calculate that weight density. Now, you have to calculate that water content. So, water content is weight of water divided by weight of solid, this divided by this into 100. Okay. That means water content, weight of water divided by weight of solid into 100. So, weight of water is given in the table, this 73.51 minus 68.78, this divided by weight of solid 68.78 minus 36.45, this into 100. So, this if you calculate, this will give 4.73 divided by 32.33 and this into 100, that is about 14.63%. So, which I have shown you here, that moisture content, this is, you can see here, this is 73.51, this is 73.51 weight of this water here, and then 68.78, this is dry soil and weight 68.78, this divided by minus weight of solid, that is 68.78, minus this is weight of empty is 36.45. So, that is this into 100, which will give you that what will be the moisture content, and this is 40.60%. So, you are having that 40.60%. So, you can calculate that water content. Now, next parameter is the dye density, and that is expressed at gamma d, that is gram per cc, that is gamma of weight divided by 1 plus m, where m is equal to moisture content. So, gamma weight we have calculated, that is 1.695 here, 1.695 gamma weight density 1.695. So, this is 1.695. So, you can write 1.695 and this divided by 1 plus moisture content. So, moisture content we have also determined, and that moisture content is about 0.1504. So, this will give about 1.473, that is gram per cc. So, you can determine the dye density if you know the weight density and moisture content. Now, another parameter which you call the void ratio. And is designated at E. E is equal to G gamma W divided by gamma D minus 1. So, G is the specific gravity, we know 2.5 into gamma W 1, this divided by gamma D. Gamma D is you have determined 1.473. So, this is 1.473, this minus 1. Okay. So, this will give you that void ratio is 0.697, and GS, this specific gravity which you have determined from the specific gravity test method. So, earlier we have determined the specific gravity from test method, what is the specific gravity of the soil, and that is 2.5. So, from this you can calculate that what will be the void ratio. So, next term we have to calculate that 7, that is degree of saturation. Degree of saturation, that is designated at S and percentage. That means S is equal to G into M, this divided by E into 100. So, G you know specific gravity of the soil, that is 2.5, and moisture content we have determined earlier, that is 0.1504, and this divided by E, that is void ratio. Okay, that is E, void ratio. We have calculated 0.697. So, this is 0.697. This into 100. So, if you calculate this, you can have the degree of saturation is about 53.9%. So, you can calculate that the degree of saturation is 53.9. So, like this, in this table for the different moisture content. So, ultimately you are having that what should be the void ratio and what should be the dye density and what should be the degree of saturation. So, from this data, from this table, you can draw a correlation between the dye density and the moisture content. So, here I am showing you this relationship between the dye density and the moisture content for different values of dye density and the corresponding that moisture content and the void ratio from the, this is the standard Proctor test. So, this is from the standard Proctor test. This x axis is the moisture content in percentage and y axis is the dye density, is gram per cc. So, for any moisture content value, so you know what is dye density. So, you can fix up dye density. Similarly, for another moisture content, you can determine what will be the dye density. So, you can get a point like this, you can get these are the point for the different. After a certain moisture content, then it is decreasing. So, initially that moisture content is increasing, dye density is decreasing. After reaching to the optimum value, then the dye density is decreasing and moisture content is increasing. So, from this curve you can determine that what should be the maximum dye density and corresponding what would be the maximum moisture content. This is the graph for standard Proctor test, and here you can see that optimum moisture content is 17%. This is optimum 17%, and maximum dye density is this, that is 1.48 gram per cc. In the right hand side also you can have that void ratio value, which I have shown into this table, that here this void ratio value, okay, void ratio moisture content versus void ratio, and from here also you can draw a different saturation line. So, this is very important from the Proctor compaction set, how to draw the compaction curve, and from the compaction curve one should know that what should be the maximum dye density and corresponding the optimum moisture content. These two parameters are very important in civil engineering and particularly for the soil mechanics, for the design of any kind of the structure. First of all, you should know that the area of what should be the optimum moisture content and the corresponding dye density. You can also draw the 0 air void line, and how you can draw the 0 air void line. For the 0 air void line, so now your determination of 0 air void line. So, this 0 air void line can be expressed as gamma d into G into gamma W, this divided by 1 plus W into G. What G is the specific gravity. So, G is the specific gravity, and this G value is about 2.5. So, you have to determine what is gamma d. So, gamma d is equal to G is 2.5 into gamma W is 1 gram per cc, this divided by 1 plus this is the W moisture content, which we determined earlier 0.1504, okay, this into that G, that is 2.5. I showed you earlier that moisture content also, that is 1504 earlier. So, from this you can calculate that what will be the dye density, that is 1.816 gram per cc. So, you know that what will be the gamma of d, and from here for a particular that moisture content and this dye density, you can determine that what should be the 0 air void line. So, 0 air void line will be like this, okay, air void line will be like this. You know the dye density, gamma dye density 1 point, that is 0 air void line 1.816, I mentioned that 1.816, and the corresponding moisture content is equal to 15. So, you can have a point like that for different water content and density, you can have a 0 air void line where the degree of saturation is 100%. So, this 0 air void line also called the saturation line or 0 air void line. So, you can draw this 0 air void line like this. Here is 8 equal to 1.816. Similarly, for the degree of saturation can be done for suppose 100%, you can draw for the 80%, 70%, and also the 60%. You can draw number of degree of saturation. Here I am showing for the constant degree of saturation, you can see this is the compaction, standard compaction curve, and this is the degree of saturation, and this is for 100%, this curve is for the 80%, and this curve is for the 70%, and this curve is the 60%, and this is 100%. So, you can draw the various degree of saturation curve, either 100, 80, 70 and 60%. So, different types of the degree of saturation curve can be also drawn. So far we discussed about the compaction test, and this is the standard compaction test, and from the standard compaction test how we can determine that maximum dye density and the corresponding moisture content. In addition to the maximum dye density and the optimum moisture content, you can also draw the different degree of saturation. Degree of saturation may be 100, 90, 80, 70, 60, 50, so that it can be done. And these are the particularly these two parameter, maximum dye density and the optimum moisture content is very important for any civil engineering infrastructure project. So, these are standard Proctor test, and this also very useful for any kind of the project where the compaction is necessary, for example for reinforced soil retaining wall, or for the road construction, or for the embankment construction. You have to check up that whether you have achieved the 95% degree of compaction or not. This is as per this ASTM code specification, you should achieve at least the minimum 95% of the compaction effort. And if sometimes that if you do not achieve or if you do not check it, so there may be a certain kind of the problem in the construction. So, one has to be very careful for the proper compaction. So, now we ended up with the standard Proctor compaction test, and next we will discuss about the modified Proctor test. And this modified Proctor test is slightly different from the standard Proctor test, and that we can discuss the next lecture. Thank you.